All right, happy Friday. So our lesson today, we're going to finish up section 372, which we started yesterday, which was solving systems where we had a quadratic function and a linear function by substitution method with algebra. We're going to finish up the textbook examples we have there, look at some word problems too, and then have some problems for homework in that. Um, I also do want to let you know that I am anticipating being back on Monday. So remember, looking ahead to next week, we'll do really our last lesson on Monday. I'm probably going to use Tuesday to try to catch up and review all the stuff we had from this week. And then we'll be in test review mode going all the way back to all the stuff we've done in this unit. Looking ahead to a test on Friday of next week. Okay. So let's go into our textbook. Our target for today. So yesterday was a linear and a quadratic function together. We're going to add in a line and a circle. We're not going to learn anything in this class about the equation of a circle, but it does work out in a manner where when we do a system of equations involving a line and a circle algebraically, it works on a lot of the skills that we had from yesterday, where it works on solving quadratic equations. So if you guys can, let's go back into that section we were working in yesterday. And you're going to have to verify these page numbers. This is an older notebook that I had, so I'm not positive that these page numbers are correct, but we're looking at example 4. Again, we're in section 372. Okay. So find this page, please. And then the question the question says, given the graph of the system of equations below, determine algebraically the solution to the system and explain the meaning of the solution in the terms of the graph. First things first, if we were given this graph, we would be able to look at it and determine the solutions to this system of equations without doing any algebra. Okay, you should be looking at this and saying, well, this circle never intersects this line, meaning that we should not have a solution to this system of equations. But this one wants us to do this with algebra. So we'll do a lot of problems where we don't have the graph. And it's like, well, we just need to determine where they would cross, if at all. Okay. And we can use the same algebra steps as what we did yesterday to do this. Okay. So if we look at the system of equations over here, the line is y equals x minus 5. The circle is x squared plus y squared equals 9. Well, we can still use substitution to do this problem. Okay, what we would do is we would take x minus 5, which is what y equals, and put this in for y in the other equation. So we can rewrite this bottom equation replacing y with x minus 5. So we'd have x squared plus, now all of x minus 5 is going to replace y. So we need to put parentheses around it. X minus 5 squared equals 9. Notice the result. This is a quadratic equation where we have a lot of algebra to do in order to solve this. So the first thing we'd want to do is let's multiply out this x minus 5 squared. Because remember, that's the same thing as saying x minus 5 times x minus 5. So let's multiply that out. We can double distribute that out. So we'd have x squared plus x squared, x times negative 5 minus 5x, negative 5 times x minus 5x, negative 5 times negative 5 plus 25 equals 9. Got a lot of simplifying to do. So let's combine x squared plus x squared. That's 2x squared. Let's combine negative 5x minus 5x. That's minus 10x. And then we still have plus 25 equals 9. Let's get this equal to 0. So we can subtract the 9 over. So we'd have 2x squared minus 10x plus, let's see, that would be 16 equals 0. Now, we have this quadratic equation where it's equal to 0. So next we need to solve it. I would say still treat this as though this was just a traditional solving quadratic equations. In the back of our head, we had this graph. We kind of know where this is headed when we try to solve this, but we should try to factor it. Okay, so let's go 2 times x squared minus 5x plus 8 equals 0. On the inside, 8 has 8 times 1, 4 times 2. Neither of those combinations can make a negative 5x. So at this point, I'm just going to get rid of this 2 in front by dividing both sides by 2. Okay, so then we would have x squared minus 5x plus 8 equals 0. And we could solve this in a variety of ways. We could complete the square. The only reason we probably wouldn't complete the square here, an odd middle term, middle coefficient here, meaning when we divide that by 2 and square it, we're going to be adding a fraction to both sides. So why don't we use the quadratic formula to solve this from here? I'm going to come over here. X equals opposite of b, so 5 plus or minus square root b squared negative 5 squared minus 4 times a is 1 times c is 8 all over 2 times a is 1. Simplify. 5 plus or minus the square root. Let's see, so we get 25 minus 32. Okay, so 25 minus 32 is negative 7 over 2. It should make sense that we're getting this answer. So we get 5 plus or minus I root 7 over 2. And if you're thinking, why would you say that? Why would you say that makes sense? So we get this answer, the super messy answer, that's 2 imaginary solutions. We'll go back to what the graph looked like. The circle and this line never crossed, so we should not get a real solution here. If we got a real solution, they would have an intersection point. Okay, so summarizing this, we would say no real solutions, right? There's no crossing point, there's no intersection point. Okay, that would be our answer. Okay, let's do some without the graph. Okay, and these are not in your textbooks. You're gonna have to flip to a blank page. You should have one right next to that or on the next page that you can use. Okay, so let's try this one. So write this one down and go to a blank page. This is not in your textbook. So write down x squared plus y squared equals 100. Y equals negative x plus 10. And let's solve this. So we use substitution. So let's take negative x plus 10, put that in for y in the other equation. So then we'd have x squared plus parentheses negative x plus 10 squared equals 100. And then got a lot of algebra. So the x squared plus negative x plus 10 times negative x plus 10 equals 100. Multiply this out. So x squared, double distribute. Negative x times negative x. Well, that's like negative 1 times negative 1 makes a positive. X times x, x squared. So plus x squared. Negative x times 10 minus 10x. 10 times negative x minus 10x. 10 times 10 plus 100 equals 100. Combine our like terms in the front. X squared plus x squared is 2x squared. Negative 10x minus 10x minus 20x plus 100 equals 100. Let's subtract that 100 over. Come up here. Then we would have 2x squared minus 20x equals 0. Became a binomial. Good practice with solving a quadratic equation that looks like this. This would be a solving by GCF problem. What tells us that? Well, we have two terms, a binomial, and they each have x's, meaning that we could factor out at least an x. So the greatest common factor between 2x squared and negative 20x, let's factor out a 2x from both these terms. So 2x squared divided by 2x, we'd have an x left over. Negative 20x divided by 2x, that'd be minus 10 equals 0. And now we can set equal to 0 each of these parts. We'd say 2x equals 0, x minus 10 equals 0. So divide by 2, x equals 0. Add over the 10, x equals 10. Remember, this isn't it, right? We, like yesterday, all our answers, we should have ordered pairs. We do have 2 intersection points between the circle and the line. Coming back to these original equations, remember we could substitute in these x values into either of these and we'll get the same y value. So I would suggest pick the linear one. So we would say y equals negative 0. There's no such thing as negative 0, so just 0 plus 10. Y equals 10. And then if we put in 10 over here, y equals negative x, so negative 10 plus 10, we get y equals 0. So our 2 points are ordered pairs that are our solutions, 0, 10, and 10, 0. So those are the 2 intersection points of this circle and this line. Oops, sorry about that. Why don't you guys pause the video here, write down this system, and try to do this one on your own. Okay, so this is how this one should have worked out. Okay, so you'd say x squared plus parentheses x minus 8 squared equals 64. Multiply this out, combine like terms, and get our equation equal to 0. So you should have got to 2x squared minus 16x equals 0. Factor out a greatest common factor of 2x from both of these, giving us 2x times x minus 8 equals 0. So x equals 0, x equals 8. And then finding the y's, come back to y equals x minus 8. So y equals 0 minus 8, giving us y equals negative 8, which gives us this point here, 0, negative 8. And then y equals 8 minus 8, giving us y equals 0, giving us the second point here. Okay? So that's the only application that we're adding in for this section. Again, it's not a quadratic. We see y squared or x squared and we think, oh, it's a parabola. The fact that this is a y squared here, this is actually the specific form for the equation of a circle. So it's just a nice application problem because when we substitute, we do get a quadratic equation as a result, which gets us practice with the same algebra. Let's do a word problem. Okay, so if we go in our textbook, flip the page to our problem-based task for here. Okay, and let's work through this one. So if we read through the problem, it says Nico and Fleur are each designing a fictional bike company for their business science class. Nico has this marginal cost of producing a bike with this equation here. Okay. And it says C1 of X is the marginal cost in dollars per X bikes produced. And then Fleur has his own, given here, with the same variable ideas here, where C2 of X is going to represent his marginal cost for X amount of bikes. Okay, so it says, assuming each student's fictional company starts manufacturing bikes at the same time, our question says, at what marginal cost will each company have manufactured the same number of bikes? Okay, so it's basically saying find the intersection point of these two functions here, right? These functions representing their marginal cost per X bikes. So we're finding where these two functions cross. Don't get confused by the subscripts in the function notation here. Remember, function notation is just another way to say y. So if it helps, let's rewrite this as y equals 0.0005x squared plus 0.07x plus 50, and y equals 2 over 5x squared, or not x squared, just x, 2 over 5x plus 62.5. Well, this is just a really messy version of the problems from yesterday, right? They're both in y equals form, so we can substitute and solve. So let's take what y equals and put in for y in the other equation. It's going to look really messy, okay? It's going to be messy algebra, but it is the same process. The other thing I'm noticing is we have decimals in all of these spots except here with the 2 over 5, so I'm going to change that to 0.4, right? 2 over 5 is the same thing as 0.4x. I'm going to rewrite this as 0.4x plus 62.5. So you'd have 0.4x plus 62.5 equals 0.0005x squared plus 0.07x plus 50. Again, this is just a quadratic equation to solve. It just looks really messy. Let's get it equal to 0. So I'm going to subtract over this 0.4x. We can also subtract over the 62.5. So we'd have 0 equals 0.0005x squared. 0.07x minus 0.4x, so that's like 0.40x. So we'd have minus 0.33x, right? 0.07 minus 0.40 would be negative 0.33. And then 50 minus 62.5, that'd be minus 12.5. You can still use the quadratic formula here to solve. So you can say x equals opposite of b, so positive 0.33 plus or minus square root b squared, so negative 0.33 squared, minus 4 times a 0.0005 times c, negative 12.5, all over 2 times 0.0005. At this point, I'm going to my calculator. I'm just carefully typing in this really big square root. Oh, it's going to keep doing that. So I'm just going to leave it like this. So let's type in square root. I'm going to add another parenthesis. I'm going to put in negative 0.33 squared. Could have just put 0.33 squared. We know that's going to become positive. Minus 4 times 0.0005 times negative 12.5. I would really just read back through and make sure it all looks right, because it just takes one little error somewhere for this whole thing to go off. So you have 0.366 if we're going to round to like 3 decimal places here. Okay, so I'm going to write that down, 0.366 over 2 times 0.0005, 0.001. And now let's find the two answers here. If you're thinking, wait, why didn't you try to make this an exact answer? Well, beyond the fact that it's super messy decimals in each of these spots, meaning we weren't going to be able to keep this exact, if we're thinking in the context of the problem, decimal answers instead of exact roots here is going to make more sense, because we're looking at X number of bikes and a marginal cost. We would rather have a decimal for those values than a square root that doesn't necessarily give us much context. I'm also going to modify these a little bit and just put a squiggly equal sign here since we did approximate. Okay, hopefully the calculator will stay. There we go. So let's put in 0.33 plus 0.36. I'm going to go a couple decimal places more, 5.9. Maybe let me go a couple more, 2.3. And then let's divide that by 0.001. So we had 695.92, comma. So the other case, the minus, 0.33 minus 0.365923, and then divide that by 0.001. Get negative 35. What was it? Negative 35.92. At this step, let's go back and think about what these even mean. So x, if we remember, represented the number of bikes we were producing. Well, you couldn't produce a negative number of bikes, so at this step, I'm just going to cross that one off. So here's our number of bikes where we have the same. We got to answer the question, though. It said, at what marginal cost will the company have manufactured the same number of bikes? So let's take this 695.92, the number of bikes, and let's put that in for y to see what we get for our marginal cost. I'm going to choose the linear one because that's a lot easier to work with. So 0.4 times 695.92 plus 62.5. I'm still going to use a squiggly equal sign here because we did approximate as we were going. So we can say 0.4 times 695.92 plus 62.5. Oops, what did I do wrong? Oh, don't need that. So we get 340.87. So that would be the marginal cost at which the company will have manufactured the same number of bikes, $340.87. Okay. So we'll see a couple word problems mixed into our homework where they come out a little messier too. The only other thing I wanted to add, so we'll be on Monday solving systems graphically. We could have done the same problem using a graphing calculator, typing into our y equals, and I did this before, into y1 and y2, the two functions. If you had just hit like zoom 6, you're going to get a negative 10 to 10 window, and you're not going to get anywhere near your solution. So after messing around with the window for a little bit, I created this graph where we have our parabola right here, slowly going up, and our line going through here. And you can scroll around on there and try to see where that intersection is. But there is a way to calculate an intersection point, if we remember. We did this earlier in the year. So we go into the Calculate menu, second trace to open the Calculate menu. We want to look at where they intersect. And we can hit Enter, Enter, just hovering over the two curves, and then guess. This is right, nice guess. And notice what we get here. 695.92, 340.869. So it's giving us the intersection point between these. If you were doing this and looking for an exact answer, sometimes it can be the slightest bit off by like 0.000 something, because it's doing an approximation on here using the calculator. But that is another tool that you can use to find that common intersection point. Okay. So that's what we have for today. Our homework, if we flip the page and go to the next page, it's going to be the practice problems for this section. I'm going to have to check the page numbers here. This is what I had on file, but it could be wrong. Again, I don't have a textbook in front of me at home. But it's the practice problems for section 372. Okay, just should be the next page from whatever this page was for the problem-based tasks. But questions 1 through 10 will be our homework. And I will be back on Monday, barring something crazy happening. So keeping that in mind, you're going to want to have the couple homework assignments that we should have done this week ready to go. I know there's one on Alex, so I can look at that separately. But we had 2 other assignments that we should have completed as well. Okay? So this is our homework. I hope you guys have a really nice weekend, and I'm looking forward to seeing you all again on Monday and getting back into some routines. Remember, we're looking ahead. We have our test next Friday. So have a good weekend. I'll see you guys soon.